to find the general solution of this differential equation. So let's see the answer. So first here writing the given dy by dx, that is equal to sine inverse x. Now after that here we can write dy equal to sine inverse x dx. After that let's include the integration on the both side. And here we can write 1 dx. So we know Euler rule. So here, so this is inverse, so inverse is there, so that we can write the first. So that here I'm going to assume this is u and here arithmetic v next. So we can use the integration by part rule uv dx. So write u, do the integration of v dx, then after minus here du by dx, and here integration of v dx, then after dx here. So according to this integration by part rule, I'm going to solve the problems. So here y, dy integration y. Then here we can write, so write the u part, sine inverse x, and do the integration of v dx. So 1 we can write x power 0, so x power 0 dx. Then after minus here du by dx, d sine inverse x divided by dx, and then here we can do the integration of v dx. So v is now x dx. Then after here this is dx. Now y equal to sine inverse x, x power 0 integration, that is x, and sine inverse x differentiation 1 divided by root 1 minus x square. Then this integration of x power 0 x, and here dx. Now the next is here we can write y equal to x sine inverse x, then after here 1 divided by root 1 minus x square, and here x into dx. Now after that here, so going to assume this is I1, and now I1 we can write x dx divided by root 1 minus x square. So for this one we need to assume, so let assume u equal to 1 minus x square, then du equal to, so this come x, 1 differentiation 0, x square, that is 2x, and here dx. Then du equal to minus 2 x dx, or we can write du equal to minus 2 here x dx. So this we can write now. So after that here in I1, so this is here x dx, plus we can put here du by minus 2. Then here or this we can write under u, so 1 minus x square, that I assume u. Now after that here I1, so this we can write minus 1 by 2, and this root u we can write u power 1 by 2, and 1 by 2 that move off, so this is now u power minus 1 by 2, and here du. Now this we can write minus 1 by 2 and integration of u power minus 1 by 2, so this is 1 by 2 plus 1 minus 1 by 2 plus 1, and if you want then you can write the c. Then here minus 1 by 2, so if you calculate minus 1 by 2 plus 1, so this is now 2 minus 1 plus 2, that is equal to 1 by 2. Okay, so this we can write u power 1 by 2, that is equal to root u, and this you can also get here 1 by 2, or we can write minus 1 by 2, and here this 2 move up, and here u value is now that I assume 1 minus x square. So 1 minus x square that I assume. Now 2 to cancel, then you can get here here I1 value that is equal to minus, and here root 1 minus x square. This is the value of I1. Okay, now after doing this, so here that I assume y equal to x sine inverse. Now y equal to x sine inverse x minus I1. This is here y equal to x sine inverse x minus 1 I1. Now here put the value of I1, y equal to x sine inverse x. I1 value is now minus root 1 minus x square, and after that x equal to y equal to x sine inverse, this is minus minus plus root 1 minus x square. So this is the general solution of this equation. So one time going to repeat, write the given, then here you can write these terms. So assume uv, then use the Euler rule, and then you can get these terms. To solve this part, assume this is I1, then after denominator part assume something, then after doing the calculation I1 value that come minus root 1 minus x square, and after including these two's, then you can get here x sine inverse x here plus root 1 minus x square. So this is the way we can find the general solution of this equation. So now in this video it's over. So thanks for watching.